Alright, today we're going to do two worksheets. One of them is called System Substitution, and one of them is called Systems of Combined Inequalities. Okay? They're kind of two different, not exactly the same type of things, but they're both relatively short worksheets, and we can get them both done today, and that'll save us a day in our lessons. Okay? So let's start by looking at number one. Alright, now I have been accused recently of only choosing the easy ones to do for you, so you have all the hard ones to do. Well, you know how evil I am, so I purposely do that, right? Okay, so I'm going to do number one for you because we need to start on an easy one to kind of see how things are going, okay? And then I'm going to let you choose which one I do, which second one I do. Because then it's not me choosing, it's y'all. Fair enough? Okay. So, you have done system substitution before, but it's been like since October. Okay? We did a little of it yesterday, and you guys struggled some. So I wanted to go back just a little bit and look at system substitution specifically. Okay? So, let's look at problem number one. We want to choose to solve for a variable. That's what we need to do in substitution. We need to choose one variable to solve for, right? Which variable would you choose to solve for in this case? Which y? So this one right here? Okay. How would I solve for that y? If I divide both sides by x, and my pen will actually work, I get y equals, I'm going to come over here, y equals 14 over x, right? Okay, what do I do with that now? I'm going to start with the other equation, but anytime there's a y, I'm not going to write a y, I'm going to write 14 over x, right? So 2x plus 14 over x equals 11. Okay, now what? Yeah, so some of you are saying, because I can tell it in your face, we have an x in the denominator. That's not allowed. That's exactly right. We get rid of the denominator of x by multiplying every term by x. Not just that term, but every single term in the problem we multiply by x. Okay? So what is x times 2x? 2x squared. What is x times 14 over x? 14. And what is x times 11? 11x. Now, I can tell on Tara's face that she just realized this is a quadratic and she knows exactly what to do. Okay? And she's exactly right. We got to get it equal to 0. 2x squared minus 11x plus 14 equals 0. So we have a couple choices here. What are our choices? We could factor, quadratic formula. Those are the main two that we worked with, right? Yeah, you can graph it if it's nice and even in pretty numbers, right? But quadratic formula, factoring will work hopefully, but if not, quadratic formula, right? So can we factor this? What's 2 times 14? 28. Is there two numbers that multiply to be 28 and add to be negative 11? Negative 7 and negative 4. That's absolutely right. 2x squared minus 7x minus 4x plus 14 equals 0. Now, this is another one of those worksheets where there's not enough room for me. Okay? I'm about to run out of room already. Are you? If you want to do your work on notebook paper, you know that's fine with me, and just staple it to this paper or something, okay? So I'm going to end up with, just looking at the first two, remember factor by grouping now. I'm going to take out an x, and I'm going to end up with 2x minus 7. Here I'm going to take out a negative 2 and end up with 2x minus 7. So I'm going to get, x minus 2, perfect, 2x minus 7. What do I do with each of those? God bless you. God bless you. I set each one of those equal to 0, right? So I get x equals 2. If I add 7 to both sides and then divide both sides by 7, x equals 3.5. So what do I do with each of those values? I would plug them in. And do you see why I wrote them on this side? Because I'm going right up there, aren't I? Okay. If x is 2, I don't know where to write this. I'll go up here. If x is 2, what is y? Yeah, because 14 divided by 2 is 7. If x is 3.5, what is y? What is 14 divided by 3.5? 4. And those are my two solutions. Will I always have two solutions? Good question. Let me answer that again. How did I get the 7? I took the x that I found and I substituted it right into that equation to find y. So when x is 2, 14 divided by 2 is 7. So when x is 2, y is 7. When x is 3.5, put it right up in that equation again. 14 divided by 3.5 will give me the y value for when x is 3.5, and that answer is 4. Okay? Questions? Then which other one would you like me to do? Four? Number 4. You ready? We even have a slight shortcut on 4, just so you know. No, we better not do that. We better not do that. Okay. What do you want to do first? Solve for a variable, right? Which variable should we choose? Should we choose this x? No, it's not going to be the easiest. Should I choose this x? If I can't choose this and I can't choose this, because I would have to somehow get them together, wouldn't I? So should I choose this y? Possibly. Should I choose this y? Possibly. Should I choose either one of the x's? No. Okay? So are we choosing first y or second y? First y because it's positive? We could make it positive, but it's not actually positive right now because that's a negative 2. See what I'm saying? What? Oh, okay, sorry, I thought it said first one. I was like, I'm so confused. All right, so if we're choosing second y, let's get that one by itself. So we need to add 5x squared. And we need to subtract 12x. So we get 3y equals 5x squared minus 12x plus 3. And how do we solve for y? Divide everything by 3. So that is our value for y. Okay? So now I'm going to rewrite the other equation, but I'm going to put that in for y. Okay? Yeah, and this is not going to work. Hold on just a second. Alright, I have 4x squared minus 6x minus 2 times 5x squared minus 12x plus 3 over 3, like that. Equals 10. We okay so far? Now, this crazy kid earlier said to me, why can't I get this one y equals? and get this one y equals and just graph them both and find out where they cross? Well, for a really good reason, because this worksheet is all about substitution. You totally could do that to check your answer, okay? But if we're solving by substitution, we need to solve by substitution, okay? All right, so now what? We just got to start simplifying, don't we? Okay, so let's see. 4x squared minus 6x minus 10x squared plus 24x minus 6. Oh, but each one of these are divided by 3. Right? Do we know 24 over 3? Don't we know that that's 8? And do we know 6 over 3? And we know that's 2. Okay. So can we combine like terms as we go? Yes or no? Is everybody okay with what we're doing? I distributed this 2 to each one of the terms, the negative 2, all the while making sure I'm dividing each of the terms by 3. What? What do you mean, am I not going to do the 10? By 3? It's only these things are divided by 3, not the 10. This one? Do you know 10 divided by 3? Say it again? Yeah, that's an estimation. And the calculator's an estimation, right? 10 is not evenly divisible by 3, so we're going to leave it like that for now. Is that okay? Okay. Because see, look what happens. Now I need to start combining like terms. And I've got 4x squared and negative 10x squared. Excuse me, negative 10 thirds x squared. What is 4 minus 10 thirds x squared? Do you know? Well, 10 thirds is the same as 3 1/3, isn't it? So what's 4 minus 3 1/3? I'm slightly ashamed at this point in time. Partly because all of you are sitting here staring at me. You're not trying to figure it out. It's 2/3, isn't it? Okay. So this is 2/3 x squared. Now I have a negative 6x and a positive 8x. 2x. And then I have these two numbers, a negative 2 and a positive 10, but they're on opposite sides of the equal sign. So could I at the same time subtract 10 from both sides? Are you okay with that? So that I get negative 12 equals 0? You okay with that? Do you guys really, really want to work with a decimal here, or a fraction? How could we get rid of the fraction? How did we get rid of the x in this problem right here? We multiplied everything by x, right? How could we get rid of that fraction right there? We could just multiply by 3, right? Multiply every term by 3 to get rid of that fraction. If we multiply everything by 3, I end up with 4x squared. Look, I said 3 and wrote 2. Sorry about that. So this is 6x squared, right? 6x squared. Oh my gosh, I'm losing my brain. How about if we start again? Let's multiply everything here by 3. What's 3 times 2 over 3? 2x squared plus 6x minus 36 equals 0. Well, now this is good news, isn't it? Why is it good news? Because all three of those are divisible by 2, right? So not only did we get rid of our fraction, we also made the problem simpler for ourselves. Okay? So if I divide everything here by 2, what do I end up with? X squared plus 3x minus 18 equals 0. So why do they make you go through all of this work just to get to something like that? Because they're evil. I know. It's all right. Now, we got to know the steps, right? We got to be able to do the arithmetic. Okay? Is this something that looks like it can be factored? If it is, try. We know from yesterday that not everything that looks like it can be factored actually can be, but we should at least try. Anything you know that multiplies to be negative 18 and adds to be positive 3. Oh, yes? What is it? 6 and negative 3? 6 and negative 3 multiply to be negative 18, and 6 and negative 3 add to be 3. Oh, it works. So we go straight to our factors. X plus 6, x minus 3. Once we have our factors, what do? Set each one of them equal to 0. So I get x equals negative 6 and x equals positive 3. Right, we have to go one more step. We have to plug them in, don't we? Okay. Now, fortunately, we already had it set up for y equals, right, on my other paper before I started to go to the notebook, so I had, or notebook paper, so I had more room. Okay. So I had y equals 5x squared minus 12x plus 3 all over 3. So what happens if x equals negative 6? 5 times negative 6 squared minus 12 times negative 6 plus 3 all divided by 3. Whoops. I'm going to start a new document so I can do this math. I'm going to make myself a fraction. Not myself, but in the calculator. 5 times negative 6 squared minus 12 times negative 6 plus 3 all over 3. Uh-oh. Look at my parentheses. My parentheses got all messed up, which gave me the wrong answer out here. How did I know it was the wrong answer? Because I'm a genius. Obviously, well, except I messed up, so I'm not that much of a genius. Okay? So I'm going to do it again. It just seemed wrong. I know it can't. There can be big numbers that happen there. It just kind of seemed weird. Okay, so I'm going to go back and check it. I'm going to say 5 times negative 6 squared, minus 12 times negative 6 plus 3 all over 3. Wow, that even seems weird, doesn't it? Is that the same thing you got? Okay, it should be 85. So let me see your calculator and let's see if we can see what you did. Oh, okay, okay. If we did it longhand, what's negative 6 squared? 36. So I have 36 times 5. Do we know what 36 times 5 is? 180. What's 12 times 6? So I have 180 minus 72 plus 3. Oh, except it's plus 72, isn't it? Because I have a negative 12 times negative 6. 180 minus 72 plus 3 is 111. Except I put minus instead of plus. So let's try again. 255. 255 divided by 3 85. Okay? We good? Everybody with us? So that means if my x value is -6, my y value is 85, right? So now I'm done. Dang it. Guys, is this hard? It's not hard. What is it? It's tedious and long, okay? A lot of the times the stuff you guys complain about being hard, it's not hard at all. It just takes a bit to get through the problem. And that's why you don't like it. Guess what? Maybe I don't either. But I can't say that because I'm your teacher. Okay? So let's take this same equation and this time plug in a 3. Okay? 5 times 3 squared minus 12 times 3 plus 3 over 3. That's a lot of 3's. Okay? I'll get over it. Don't worry. So I have, well, 3 squared is 9. I don't need to do that in my calculator, do I? 9 times 5 is 45. So 45 minus, well, I can do that in my head, 36 plus 3. And if I divide that by 3, I get 4. So again, just if we needed to do it by hand, we could do 3 times 3 is 9. 9 times 5 is 45. 12 times 3 is 36. And then plus 3, right? What's 45 minus 36? Anybody? 9. What's 9 plus 3? 12. What's 12 divided by 3? 4. So that means when x is 3, y is 4. So for this particular problem, I have 2 solutions. Okay? I'll even give you a hint. On the other 4 problems on this page, you get 2 solutions every time. Okay? 2 solutions every time. Got it? Now, let's do something easy that's not time consuming. How about that? Okay? Let's look at this page. Again, this is something we have already done. We've done it before in October. Okay? So we're remembering. Plot points and shade regions to show the solutions to each system of inequalities. When we have a system of equations, we graphed, and the solution was the point of intersection. When we have a system of inequalities, we graph, and then we shade. How many possible solutions are there? An infinite amount, right? Anywhere that's shaded is a solution. Okay? All right, so let's fill in our table. I've got -2. What's -2 squared? 4 minus 2? 2. 4 minus 2 is 2. Yeah, that's right. Minus 6? -4. What about -1 squared? What's that? 1 minus 1? 0 minus 6? -6. 0 squared? Plus 0? 0 minus 6? 1 squared? 1 plus 1? 2 minus 6? -4. Can anyone guess what the last one's going to be without doing any math? How do you know it's going to be 0? Because it's symmetric, remember? Okay? But just pretend we don't know. 2 squared is 4. 4 plus 2 is 6. 6 minus 6 is 0. Got it? Okay? Now this one's way easier, isn't it? Because it's a line. And once we do a couple of these, we don't have to do any more. Why? -1 plus 3? 2. 0 plus 3? Do I have to do any more? 0, 1, 2, 3, 4, 5, 6. And in a pattern like that, linear functions, let's graph them. Okay? I graph this first one in purple. -4, +6, -3, 0, negative 2, negative 4, negative 1, negative 6, 0, negative 6, and 1, negative 4, and 2, 0. Ooh, I almost connected the points. Can I do that? When I'm graphing inequalities, what do I have to be super careful of when I'm actually going to graph it? Is it solid or dotted? That's exactly right. Okay? Is this one solid or dotted? How do you know it's solid? Because of the equal sign, right? Okay? So I'm sure you did a way better job than I did. Okay? Now, if I was shading, I'm not going to, not quite, but if I was shading, would I shade inside the parabola or outside of the parabola? How do you know I would shade inside? Because you chose a point 0, 0, and you plugged it into the equation. 0 is greater than or equal to, let's see, 0 plus 0, 0 minus 6. So you get 0 is greater than or equal to negative 6. Is 0 greater than or equal to negative 6? Yes. So I'm going to shade toward the point that I chose. And in this case, the point that I chose was inside of the parabola, so I'm going to shade inside of the parabola. You okay with that? Now, I'm not actually coloring yet, am I? Okay. Now let's graph the line. Negative 3, 0, negative 2, 1, negative 1, 2, 0, 3, 1, 4, 2, 5, 3, 6. Okay? Wait, is this one solid or dotted? Solid. Now, should I shade above or below the line? If I choose a point 0, 0, in this case it happens to be below the line, I get 0 is less than 3. Is 0 less than 3? Yes, so I shade toward the point that I chose that made it true. So where should I end up shading for this problem? So that's the solution, right? Now, but it asks one more question just to make sure that you understand what's going on. List some points in the shaded region. List points in the solution. What? Can we? Can we choose 0, 0? Is it in the shaded region? Yeah. I want at least 3 points. At least 3. So somebody else give me another one. Negative 1, negative 1. Is that in the shaded region? Absolutely. Negative 1, negative 1. One more? 1, 3. Ooh, that's pushing it. 1, 3. But it's still in the shaded region, isn't it? Okay, so here's a trick question. Are you ready for my trick question? What about negative 2, 1? Negative 2, 1 is right there. Is that in the shaded region? Why are you saying yes so proudly, confidently? It's on the line, and our line is solid. That's exactly right, okay? If for some reason the line was dotted, could I choose a point on the line? No, I could not. Okay, this particular problem, both of these are solid lines, so I could choose any of these points on either one of these, well, this line and this curve, right? Okay, any questions about that? All right, so what I need you to do for the weekend, 3 and 5. 3 and 5. On system substitution, 3 and 5. And on systems of combined inequalities, I would like you to do 2 and 3. So you're doing 3 and 5 on system substitution, and 2 and 3 on combined inequalities. What does that mean about the rest of them? They are extra credit if you choose to do them. Okay? Are there any questions? You can always come by to your tutorials to see me if you have any questions, correct? Any questions?